And let's look at practicing reading vapor pressure curves and determining whether or not a substance will boil. This is going to be doing the practice problems on page 42. Okay, so we're going to be looking at this vapor pressure practice. One of the first things that we need to do is when we look at the diagram, we know that it is reading vapor pressure. So we're paying attention to the fact that this is vapor pressure. It is measured in torr. That's going to help us with our normal pressure. And we also just need to know that it's temperature. So these are three different substances, substance A, B, and C. And these are the temperatures and their matching vapor pressures measured in torr. Okay, so when we look at the questions at the bottom, we're going to start by writing our AVTB. And so if you're not certain of that chart, you can go back to the previous video. But this is looking at air pressure, vapor pressure as it relates to temperature, and then whether or not the substance boils. And that helps us kind of fill in the information that it's asking for. Okay, so if we look at our first question says, at what temperature, so it's asking me for temperature, at what temperature would this substance begin to boil? Okay, so I'm going to go ahead and divide my vapor pressure and temperature columns so that I can fill that information in. Okay, so at what temperature, so it's asking me for the temperature, would liquid A boil at atmospheric pressure of 400? So I know the atmospheric pressure is 400, and yes, it's boiling. So I know that in order for it to boil, the vapor pressure must be at least 400. So I'm looking at substance A, so I'm going to go up to my graph, I'm going to find substance A, and I'm going to go to 400. And then I'm going to read over to 400 and see where that drops down. And it looks like to me that that drops down just shy of 40, so I said about 38 degrees Celsius is what temperature it would boil at. If we look at substance B, we're still looking at 400 torr, so that means that the vapor pressure needs to be 400 in order for it to boil. So I look at substance B and I go from 400 over, I hit the curve for B, and then I drop down and see what temperature, and that looks like it's about 70. At 70 degrees Celsius, the vapor pressure would be high enough to begin to boil. For substance C, same thing, I'm looking at the vapor pressure curve for C. I know that the pressure needs to be at least 400 because the air pressure is 400. And so in order for it to boil, the vapor pressure must be 400. I go over for a vapor pressure of 400 for curve C, and I need an air pressure of at least, a temperature of at least 100. Okay, now we're going to do a similar process, but we're going to be looking at a temperature and then comparing it to the atmospheric pressure. So it says, how low must the atmospheric pressure need to be? So I'm going to be looking for the atmospheric pressure in order for liquid A to boil, so it is boiling, at 35 degrees Celsius. Okay, so I'm going to go to 35 degrees Celsius. I'm going to go up to the curve for liquid A, and I see that the vapor pressure at 35 degrees Celsius is just under 400 torr. So I'm going to say that it's about 375. So in order for it to boil, the air pressure has to be 375 or lower. So anything below 375, my substance would boil. For liquid B, same process. The temperature is 35. It is boiling. And so I'm going to look and I'm going to say, okay, for substance B at 35 degrees Celsius, it looks like my air pressure is just under 200. My vapor pressure is just under 200. So I'm going to say about 175. So in order for that to boil, my air pressure must be something below 175 torr. And then lastly, for liquid C, my temperature is 35. And so here is where 35 crosses the C diagram. I look over and that looks like it's about halfway between 0 and 100. So I'm going to say that that's about 50 torr. So in order for it to boil, the air pressure must be 50 or lower. And so I get 50 torr. Okay, and so now I'm going to look at those last three questions. What is the normal boiling point of liquid A? So normal boiling point is when the atmospheric pressure is normal. So I know that this graph is measured in torr, and I have on my notes page that normal for torr is 760. It is boiling, and so I need a vapor pressure that's at least 760. So when I look at substance A at 760, it looks like the temperature is something above 50. So I'm just going to say 50 degrees Celsius. You may read that to be like 52 or 53. But as long as the temperature is somewhere above that, my substance will begin to boil. Okay, I'm going to do the same process for liquid B. So the normal boiling point is 760. That means Our normal air pressure for boiling is 760, so that means my vapor pressure must also be 760 in order for it to boil. So I'm going to look for substance B. I'm going to go over 760, and then I'm going to drop down, and it looks like it reads something around 80. So as long as my temperature is 80 degrees Celsius or higher, I will boil. And then lastly, for substance C, if it's normal, the air pressure is 760, which means my vapor pressure must also be 760. So I go across 760 to C, drop down. It looks like it's right at 110. So I need a temperature of 110 or greater in order to be able to boil. Okay, my last question in this says, which liquid has the strongest intermolecular forces? Intermolecular forces basically mean stickiness to each other. So how are those particles sticking to each other? Well, something that boils easily, those particles are able to escape easily. So A is able to boil at pretty low temperatures, so I would guess that it has very low intermolecular forces because those particles aren't sticking to each other. However, when I get over to C, that requires a much higher temperature in order to be able to boil. So those particles must be pretty sticky. And so I would say that the strongest intermolecular forces would be substance C because those particles like to stick to each other and not escape into the gas phase easily. Hope this helps.